Years ago, but we had Homo erectus, Homo habilis. The Neanderthal was very late. I don't know why we made a different species, because species aren't supposed to have sex. But now we know that Neanderthals and Homo sapien were doing it, as well as killing each other. Well, finally the Neanderthals are gone and the humans are here, and now you look at our population of Homo sapien, your abundance on this planet, humans, has been low all this time. 2 million years ago, you were only in Africa. There wasn't a single human in North America. They stayed there. Population stayed small. And then finally, as the Ice Age came to a great climax 14,000 years ago, with so much ice, sea levels dropped so far. It is thought, you've heard, that from Asia, others argue by boat, that humans, Homo sapiens, crossed the ocean on the Aleutian Islands. There's a land bridge, and it quickly, at 14,000 years ago, quickly inhabited all of the Americas, from Alaska, North America, through Central America, down into South America, all the way to Patagonia. We can see, and many civilizations, the Incas, the Mayans, with brilliant intelligence, and some perished. And then your populations took off. We reached our first billion people on this planet in 1830. First billion. It took 2 million years, or 4 million years, to get a billion people. Well, all that sex, what was going on? Well, they were killing each other too, and dying, and not living long, and not intelligent, perhaps, in some areas. And then you doubled and had 2 billion people by 1930. 3 billion people by 1945. 4 billion people, 5 billion people, 6 billion people in 1999, and this year, we're going to 7 million. Wow. Population's out of control. And now, so for most of Earth time, you weren't here. For most of human time, the Earth did not know you were here. In the Americas, you weren't even here at all until 14,000 years ago. Who owns this place? And suddenly, for the last 100 years, the Earth knows you're here. All right? Wow. So this is what we're going to be doing today. I'm now going to repeat some of this with a PowerPoint, but mostly to emphasize what I've just said and re-emphasize. Where's my thingamajig? Hey, Tiger. I call him Smiley. Really got bad breath. And I got to have my little clicker. All right, so I'll take a momentary pause. There you are. Okay. Oh, wait. So where does air, land come from? It was fuel. And our fuel, again, was radioactivity. Where the Earth is hot, it melts, it comes back.
Yeah.
Not go to the bathroom?
Yeah.
Oh! So there it is. Well, look at Mount St. Helens blowing, and look at all that volcanic ash blowing out with clouds of gas as well. I think I got a pointer here. Wow, look at that. And so that fuel, uranium, thorium, potassium, and some aluminum, as I said, which is now extinct. Where it's hot, the Earth melts. The Earth is now cooling. But it is hot, and it is mobile. Okay, where we have rifts, East Africa Rift Valley, where making oceans, where the lands move, the continents are moving, continental drift, it's all there. But here was early Earth in an artistic view. Look at that, the sky is black, there's no atmosphere, no volcanoes yet, pounding away, smashing, cratering, early Earth, great mop-up. No air or water yet, all right, 4.6 billion years. Metal, rock, carbon, and comets of ice. It sounds like a rock band to me. There we go. And then we melted. The first thing we formed was the Earth's core. I'm melting. So the iron sunk. I'm melting. And in the outer half, they started rising. We started melting the mantle, and I'm going up. And where the mantle melted, this is key. Water and carbon dioxide lowers the melting temperature of rocks. And so where it melted is where the water was and where the carbon dioxide was. And so that lava, you look at lava, it's full of holes. You know why? Because it melts where there's water and carbon dioxide, and that dissolves in the magma, held under pressure. When I take a champagne bottle and unpop it, bubbles come out everywhere. Let's have a beer. Y'all drink, don't you? Oh, you're packed. God, you promised and you came to me. And so, let's do that. We'll open a beer and watch it. I mean, I have that beer bottle sitting in front of me. You see any bubbles in it? No. Uncork it. What happens? Out of nowhere. Mama, it's magic. Oh, honey, just drink it. Oh, that's not right. Okay. And so the earth became differentiated with a core, inner and outer, and a mantle, and a crust. Today, our earth is cool. It's cooling. It's slowing down. It's gone through part of its radioactivity. All right? The core has cooled and it's solidified. The outer core is solid. The inner core is liquid iron. The outer core is solid iron. And that's a remarkable area. It's liquid iron. Liquid iron moving over solid iron. Liquid iron and solid iron both conduct electricity. When you move electrons past each other, when you move substances that can conduct electricity past each other, you create another field, a force, called magnetism. The earth became a magnet. When I take a submarine and move it through water, the submarine conducts electricity. It's metal. Water conducts electricity. Get out of the pool when it's lightning, right? When a submarine goes through water, it creates its own magnetic field. When we learned this, we learned to track submarines during war because they had a magnetic field. They had to stop. Oh, then we lose the magnetic field. Okay, and so the earth became magnetized. It's a force. It's a beautiful force. Our magnetic earth protects us. It gives us a beautiful magnetic field that deflects the plasma from the sun. It protects us. Now, evidence of this, I want all of you to think about where north is. Some of you have a sense of direction. Some of you, many of you, are absolutely clueless. Those that have a sense of direction know the force. You have iron in your brain. You do. And those like me have no idea. You put me in a store like Blumenberg's and I can't find my way out. I don't know what door I came out of. I'm lost. I run to any door I can, go all the way around the building trying to find where I parked my car. Okay. Close your eyes and point north. Point north. All of you. Close your eyes and point north. Open your eyes. Now you've got to point. You've got to do this. Everybody point. Now everybody look at everybody. Holy cow. Now, you're all over the map. Which way really is north? That way, right? All right, now some of you have the field of force. Our magnetic field is remarkable. It actually flips at times. It lowers. It starts over again. But it protects us. That's our core. All right, moving liquid iron over solid iron, there it is. And so history of the world. We started with a big bang, 13.5 or so billion years ago. Stars started forming. Clouds of gas would come together by gravity and ignite stars. Our sun is a fairly young star. And then once it burst, the planets start forming also by gravity. All right, the great mop-up. And then, I'm melting. Core forms and then finally the crust and atmosphere. So that's our world. So the earth was melting even as the great mop-up was winding down. It was already lava breathing out over the earth, forming the crust, the atmosphere, the oceans, and life. So the earth has a molten core, gives us our magnetic field north and south. It's a dynamic field. It shifts. It actually moves because the turbulence of our core, outer liquid moving over inner solid as the earth spins. Those two both conduct electricity. I don't know how it happens, but you move electrons over electrons, you get a magnetic field. And our core is molten, and our mantle is also partly molten. 5% melt. Our mantle of our earth is churning in these huge convection cells where it's rising, where the convection cells rise. I get continental rifting, moving, ripping continents apart and making ocean bases. All right, and where the cells are coming. So here's that moving, and here's this. I'll continue it here. The next cell has got to go this way, right? Those cells are colliding. Those convection cells are colliding, making subduction zones, taking ocean crust and subducting it back down into the mantle, driving it all the way to the core mantle boundary. So our Earth is alive. It's alive, moving the continents around, slamming them into each other, breaking them apart all over again, taking part of our ocean and sending it down into the deep mantle. So that is shifting of the plates, and it's called plate tectonics, which we'll talk about next week. So I'll put my stuff down because I had to do some gyrations. But you get the idea. So there's the convection cells. Every cell moves in an opposite direction to the other. These have to go this way. So those are going clockwise. That means this one here has got to go counterclockwise. You two, I'll kill you. Be quick. I am. And so earliest Earth. There, the comet's still coming in. There's our moon. Knocked out of the Earth very early. Went into Earth orbit. Continued to form on its own. It's cratered as well. First earthquakes and volcanoes, 4.6. Early atmosphere, 4.6. And the lost chapter up to 4.0. Wow. Those, how do we know this? The old rocks are there. The oldest rocks are 4.0 billion years, and there they are. Now, all these darker, they're called Archean. This is out in Wyoming. This is in the Superior province. It goes all the way to Hudson Bay. And another one up in here in Upper British Columbia. And all the continents have got these early seeds, Archean rock, with fossils 3.8 billion years or younger. They're there. But the fossils in those rocks are not abundant. Life was not abundant then. There they are. That's what the oldest life looks like. All right? Sedimentary rocks, metamorphic and igneous. You know there are three kinds. It's the sedimentary rocks that are going to have fossils of life. Here we go. We're looking at the Grand Canyon. Layers and layers, chapters, like pages in a book. And as you go down, down. You're getting into older and older layers. Nicholas Steno was recently featured on Google. Did you see it? He discovered that rock layers, if you go older, or as you go down, are older. He deduced from that the Earth is a lot older than what the Bible said. It was really ancient. That really disturbed the religious order of the world. Nicholas Steno. He broke it open. So the Grand Canyon. Here we are down at the bottom of the Grand Canyon, and as we travel downstream, we're also going into deeper and deeper rocks. And that's where you see what's in there. What was living in. Well, go crack open a hammer. You want to be a geologist? You love to smash rocks with a hammer? Come with me. It's a hoot. And you go into those rocks, you don't find a lot of fossils. Life was not very abundant, but you keep looking, and there it is. Wow. Hell, that's no different than algae today. Okay? That's algae. Algae, bacteria, later fungi, all one-celled, can live in the most hostile environments. All right? They thrive. The beginnings of life. This is called the emergence of a whole new field of geology and biology together, called geobiology. All right? The beginnings of life. And the beginnings of life are like that life that exists today in the most hostile environments. You want to see what the earliest life looks like? Go to your bathrooms. Go to your bathrooms. go to the sink. Stand over the sink and look down that drain and holler down, hello down there. Because in your bathroom sink, there's a loop underneath, right? If you ever taken that thing apart, it's awful. It's full of green, smelly, yucky slime. No, it smells. But it's thriving, and it's green, and it's thriving. And yet, what do you put down that bathroom sink? You brushed your teeth, spit out the toothpaste, your mouthwash went down, soap and water, hot water, cold water, and last night leftover beer went down, and oh, they're coming to inspect, get rid of the alcohol. You pour it down there. And the algae sitting there thriving in this hot, cold, alcoholic environment. Yeah, beginnings of life. There it is. All right? And then that life continued to evolve. This is still bacteria, but it looks a lot like worms. Right? And then we had our first worms, our first animals, 800 million years ago. What do worms do? And so the spiral of life. So I told you now that you came to Earth as a shooting star. And you came out of Earth through a volcano, right? And then you began as life at the bottom of a hostile ocean as one-celled microbes or slime. Isn't that amazing? Evolution. Come on in, get in here. Evolution. So an evolving planet, and eventually that life breathed in and made limestone and sucked in our atmosphere, which used to be really thick, gradually thinning our atmosphere. Thank goodness. We'd be impressed. Leaving behind a much thinner atmosphere with time that was mostly nitrogen. 78% nitrogen. 21% oxygen. I mean, aren't you glad it's not the other way around? Aren't you glad we got all this inert gas called nitrogen? Can you imagine lighting a cigarette in 100% oxygen atmosphere? Holy cow. Blow up. And so we go through Earth time, 4,600 million or 4.6 billion years. This is the Archean. And then what we call the Proterozoic. But right here, at 570 million years, we start the Phanerozoic. And that was the life explosion that we divide up into Cambrian, Ordovician, Devonian, Permian, all the way up, and fossils. Crawling around the ocean floor, trilobites, like cockroaches. And right there, life just exploded. It's still in the oceans. Evolution, still in the oceans. Nothing on land yet. Look out. And then life became more complicated. Ammonites and spirals. They're multi-celled now, don't you see? They're animals, and they're clinging to the ocean floor, living and thriving. Now fossils, as I showed you, snails and clams. Look at that. Brachiopods, sponges, and beautiful corals. Don't you see? It was a Garden of Eden. It really was a Garden of Eden on the ocean floor. Tell SpongeBob. SpongeBob knows this. And it's sedimentary rocks that tell us. The sedimentary rocks preserve the fossils. They also preserve the environment of deposition. We can tell when the sediment is out in the deep ocean, or did it form in the shallow marine? Was it in an organic reef? We can separate that from the lagoon. Beach sand is different. Apply out in the desert. River environments all make different sediments. And they all have different fossils. So we can reconstruct the Earth at any time, knowing what the environment looked like and who was living and who was dying. And here's an example. Walk out with me to a river, and you're going to find boulders and cobbles everywhere. So therefore, rocks that are made out of conglomerate and sand represent an ancient river that no longer is. We can see who was there. Let's go look in your backyards, okay? And ripple marks on sandstone, fossilized. There they are. Wow. And then life. Suddenly we're looking at land rocks, and all those land rocks up to now had no fossils. And then life on land. Those are ferns. Just like ferns today. Look at that. A maple leaf, just like today. And then with all that life on land, including plants, our first beds of coal. We are in the fossil fuel era. We depend on it heavily. Coal, natural gas, and petroleum. And it all comes from abundant life. And Earth now has got abundant life. Coal beds started being made. Oil, natural gas, moving around. And then walking on land. Dinosaurs, big and small. Some of them flying and becoming birds. Look at the size of that track. Boom! Not the biggest extinction, but a pretty big one. The great meteorites hitting off the Yucatan Peninsula. Might have been a rain shadow of these. Usually they come in multitudes out of bigger meteorites. Just before they hit us, they break up into many. But look out! Look at the size of that thing. Whoa! Whoa! This is all artistic views, but you're toast! I'm already dead. And so, at the Cretaceous-Tertiary boundary, here's all the extinctions. So here are the number of families on our planet, say really low, and then the life explosion. Life, God, we're really evolved, and then we recovered a little bit. Mother Earth having a good time, got a great big old eraser. And then she says, oh, yes. 3. Permian-Triassic boundary, the largest, 95% of all families eliminated. And then they rebounded. And then finally we got back up here in the age of reptiles, and there was the dinosaur extinction. So 5 big ones. So it's interesting. You know, we're into an extinction now. All right? Saber-toothed cat's no longer here. Wow. So I can go to that Cretaceous Tertiary boundary, and the bones are there. Coated with iridium. An element rare on Earth but found in meteorites and asteroids. Iridium coating the death of these bones. Look at that. Look at it. Wow. Bones everywhere. Life now, too much death. And where is that rock layer? Right here. Here are rocks layered. These rocks here, this is in Dinosaur National Monument in Colorado. The rocks above, no dinosaurs. And a whole new life scale for the planet. The number of reptiles greatly diminished. You go below, full of dinosaurs and other reptiles that did not survive. And it wasn't just reptiles. A big, big extinction. And so then the age of mammals. And I know I'm using LA as an example. I'm not been here long enough to know it was walking down Boston streets. But during the age of mammals, here's a mastodon coming down, mammoth, saber-toothed tiger. Hey, there you go. We did have elements. We had buffalo. We almost killed them. We have some of those left. Look at that mastodon sitting down in a museum, walk down Wilshire Boulevard. I'm sure they were walking here too. This one only 33,000 years ago. We're in an ice age and we're coming out of it. Here are pigeon-toed, running toward you, some kind of early mammal. And then humans. 14,000 years ago, 15,000 I'll say, during the Ice Age, sea level drops and they come cascading out of Asia into Alaska, down through North America, making settlements down into Mexico, down into Central America, into South America, all the way to southernmost Chile. Look at that. Spread of Homo sapiens. The end of the Ice Age. So the big numbers that you'll see, I'll put this up online for you so you'll have it there. But 4.6, the origin of our planet. 4.0, the oldest rock. 3.8, the oldest fossil. 2.2, our Earth began to have an oxygen-rich atmosphere as Earth breathed in and made dolomites and limestones. 800 million years, the oldest animals, but in the ocean, light explosion at 570, life on land at 400, big-ass extinction, bad word, at the Permian-Triassic. A second great extinction at 66, that's the Cretaceous boundary. Okay, wow. 4 million years, the earliest humans, 2 million years, more humans, and so there we all begin. 2 million years was the beginning of the Ice Age. So we go back and look at the hominids, and there was some Australopithecus, had many different varieties. They were pretty much human-like, but they're not Homo genus. That was safer up in here with Homo habilis at 2.5 million, Homo erectus at 1.5, Neanderthal just at 100,000 years ago, and then Homo sapiens. Wow. Doing lots of reproducing. And there it goes. And then finally, get in here. I didn't even see you go out. How did you get by me? I got eyes on all the room. And so when we look at the abundance of humans on our planet, they were really very small for all that time. She did not know you're here. And then finally we get up our first billion people at 1830. Second billion, 1930, third, 1960. I guess I misquoted that. I said 1945. 1975, 4 billion. 1987, 5 billion. 1999, 6 billion. And we're going for 7 this year. All over the world. And of course, you know it's different depending on countries, right? The growth of population in the United States is fairly stable. You go to other places like China, they're booming, although they have put down, a ruling about how many children, so they're topping off. It's interesting. All over the world. Population, is it going down? Today, is population increasing or decreasing? All over the world. Increasing. You've got it. You've got it. Wow. And so that's big issues, all right? You want a job for life? Think about all the issues that our growing population causes. Because these are jobs, whatever they may be, won't go away. We're going to be talking about all this throughout this course. All right? The supply of energy. The getting rid of air pollution. Issues that are simply never going to go away, as the Earth now knows we're here. So Earth is unique. Are there other Earths out there? You bet. Have we found it yet? No. But we're looking. But we've got life. However we're unique. We got life, but we're looking also at Mars and the moon, Ganymede around Saturn. We have an internal heat engine that you now know. We've got a perfect size. If we were too small like the moon, we wouldn't have enough gravity to hold an atmosphere. And if we're too big like Saturn, screw it. Who's going to be able to walk around that? Because you have too much gravity, right? If you're too big. So we're just right, just right. We are a differentiated planet with a core mantle crust and an atmosphere because the Earth came alive. We got a magnetic field that protects us from the solar plasma. We have an atmosphere that insulates us with like a blanket on us at night, keeps us warm. It filters out UV radiation, burns up most, not all, the meteorites, and it provides water. And we have a dynamic planet of shifting continents we call plate tectonics. 14 different plates that we'll talk about next week. Without earthquakes and volcanoes, never mind, something's going to happen here. Except I hit the wrong button twice. Without earthquakes and volcanoes, you would not be here. Okay? It's a crazy place. There we go. Right now. What was that? Run! Whoa, what was that?
Calling all angels.
Oh!
I need you near
We're
to
the meteorites come in. Look at that thing. That hit land. Oh my God, here's another
I
one.
miss you dearly.
Here's another one. Going right at the Yucatan Peninsula. Look out! Big. Sometimes they blow up in the sky before they hit. Look at that. The air cushion ahead of it, blowing the water. Going into near flat trajectory now. It's hit. It hit. Wow.
I've been waiting.
Concussion waves, tidal wave moves out. Oh my God, oil derrick. Birds, fly. Inhabit the earth, you're all that's left. Lovers, run. The ocean is going out, it's coming back. They died together. That's your liberty. Obviously this film was made before the towers came down. Look out, tidal wave, get in here. Why is he holding at me? Oh my God. Oh boy. Through the building. Oh. The screams. Oh. This is how extinctions happen. One way. Wow. Pretty cool stuff, huh? Wow. So, I've been doing this a long time. I think this picture is like 1978 or 1981 or something like that. That would be your parents. They happened to be living in California. Anyway, it didn't mean. I remember one time I had a student stand up and said, after I was doing all this doomsday stuff, she says, "This class depresses me so much." Did I tell you about this? This class depresses me so much. I'm going back to my room and I'm just going to write poetry. And I had another student stand up in this class. I used to call it God, Genesis, and Geology. And said, "I did not